Okay, a second type of bonding. These are metallic bonds. These are kind of weird. Make sure we know the difference between metallic and ionic. Metallic bond is when a metal atom donates, not to be confused with ionic bonding, its electrons into, and then vocabulary word, the sea of electrons, or the electron sea. We'll talk about that in just a bit. Metallic bonds are found in metal to metal bonding. You'll know these because they look weird. Normally you're dealing with transition metals here, but they can be group 1, group 2 as well. These are called alloys. So like your gold necklaces, your silver rings, all those things are going to be actually alloys of each other, so metallic to metallic bonds. So delocalized electrons. Knowing how metallic bonds work is all revolving around your knowledge of delocalized electrons. These are electrons that, when they're in the electron sea, they don't belong to any one particular atom. What this means is that the electrons aren't localized to any one place so that they can move around. Alright, so put it all together. You have metal bonding to a metal, so every atom inside those metals is going to be, every electron of those metals is going to be donated to the sea of electrons. They're kind of socialists. And those delocalized electrons don't belong to that one atom anymore, so they can move around, and that gives it some properties. So here are your properties. You should be able to look at these pictures and figure them out. You're going to be responsible for being able to do that. You're also going to need to be able to describe what is happening in these pictures. So the first one, first let's look at picture A right down here. Picture A shows you delocalized electrons. It shows you that these electrons can move around. They're not belonging to any one atom. So if you take a look at this little guy right here, these are supposed to be gold nuclei. This atom has become delocalized to way down here. This atom, for that proton, has been delocalized way down here. So these can move wherever they want. So they have a high melting point and boiling point because the delocalized electrons act as a glue. So what that means is we get layers of atoms that are kind of sandwiched between each other. So you kind of have an atom and then the electrons there. You have another atom and the electrons there, and they're all glued to each other. Now these are kind of fluid. They do move around, but they all kind of act as a very negative shell or glue for these sticking points. That's why you can pick up a piece of metal, even though the electrons aren't bonding to each other's atoms, they're still going to hold together because that electron C acts as a glue. So metals are ductile and malleable. Remember, ductile is lengthening into wires, and malleable is being able to be hammered. If you take a look at part D right here, that shows you ductile malleable. Think about that arrow as a hammer. So they're ductile and malleable because even though they are glued together, like I mentioned, they are fluid. The atoms can actually can roll. Wow, I can't spell. Around each other. So you can mold them. That's why cars can look just about any way you want the car to look. So metals are good conductors of electricity. So think of this thing down here, kind of looks like a battery with a negative end, and you can draw the little head for the positive end down there. They conduct electricity because the delocalized electrons are free to move in response to electric charge. Electric current. we take a look at this picture, let's say we've got an electron right there, red, electron right here. You put a charge through it. Remember, electrons are negatively charged, going all the way back to the cathode ray. It's going to go to the positive end of that current, so that since that electron is not stuck to this atom, it can go all the way to that current. Pretty simple concept. Then good conductors of heat, basically the same thing. That's part C down here. We'll do that one in green. I'll show you before I explain it. Once again, it's going to start with delocalized electrons. Once again, since they're delocalized, they're free to move. And when you heat something, we'll get to this in later, but it's actually just a change in how fast these electrons are moving. So think about this as a pot. This is your heat source right here. Here's a little bitty atom. You heat up the pot, and that atom is going to move faster. It's an increase in kinetic energy. So what that happens is this one's going to go bounce up at that one, and you see how it kind of ricochets off of all those nuclei, all those protons. And that's going to cause everything to vibrate, and that's going to increase heat throughout from the heat source all the way to wherever the metal is. So delocalized electrons move and bounce off of nuclei. Transferring kinetic energy. All right, and luckily there are no Lewis dot structures because not any one atom has any specific amount of electrons here. The key with these is knowing electron C, what that means, knowing what delocalized electrons are, and being able to describe how delocalized electrons gives it these properties. Ductile malleable, electricity conduction, and heat conduction. You've got to know all of those and be able to recognize it based on the picture as well.